Welcome back. So you have started watching videos on genetic algorithm, and now you are trying to understand by solving a toy problem by hand all the steps of a genetic algorithm, which is in silico inspired by organic evolution, right? Which Mother Nature optimize its species, right? Say this is my um, function which I am trying to optimize. So f of x equals to 15x minus x squared. It could be anything. Of course, this function I will not generally optimize using genetic algorithm, but we are trying to understand how it works, because it's a calculus method, you can just easily optimize it, right? So it's 15 minus 2x. I am differentiating this with respect to x and making it to 0. So x equal to 7.5. So this is for x 7.5. The function will be optimum, and whether maximum or minimum, you see. Again, if you so function is negative definite. So this value will give the maximum value, right? So this by calculus method we know, but we are not going to do that here. We at the most will verify GA's result, whether it is tallying with actual results, right? So this is my function, which you can call fitness function also, and x lies between 0 and 15. Okay? So first problem is in genetic algorithm you will have to codify. Okay, so how many so chromosomes you will have to design, and for codification, this is very interesting one. First you will need to figure out the fitness function, but here it is given. If it is not given, there are methods which can allow you to calculate fitness function, to determine fitness function, and in many cases the error function can be used as a fitness function, because error minimization can lead to the best solution, right? Anyway, here I need to figure out chromosomes. So binary coded, so 4-bit. So these are the chromosomes, right? So these are integer values, and these are in terms of chromosome. Okay, binary coded chromosomes. Okay, and each chromosome has fitness value. So put this value here. So this is 1. So its value will be 15 into 1 minus 1 square, 14. So fitness value is 14. So here it is 2. So 26, like that. Here it is 3. So 3, 15, so 45 minus 9, so 36, like that. So you can calculate fitness value for each chromosome, and now you will have to determine that how many chromosomes you will take. That is again your decision. So let us assume that we have decided to take 6 chromosomes, and out of 15 chromosomes, what are the 6 which you should select? Okay, thumb rule is that you have calculated fitness value. Those who have higher fitness value in order you can select. You see, 56, 54, 36, 44, and sometimes some chromosomes can have less values also. You select less values so that the population can have heterogeneity. This is very important also, because you are trying to figure out here. If I just now tell you the story, you have a function, right, and the function could be like this. There are many optimal points, right? So we want our search, and we do not know what is the nature of this function. Through search, we are trying to figure out the optimum value like this, right? So if you have fresh population, and sometimes, okay, you are just running algorithm and your search can be trapped here. So to come out from the trap, I have mutation operator, okay, and otherwise, so I have 2 operators: crossover operator for mating and mutation operator. So using these 2 operators, I am running my genetic algorithm step by step, and you see at the end you will get only two survival chromosomes, which will give the uh, value, some value, and then average of them you will see near about 7.5, which actually it should be. You should get. Now see how. So there is a concept called Rolex Wheel. Each chromosome you see you have selected 6, and each chromosome has a fitness ratio. Okay, that means what is the fitness ratio of this chromosome? 36 divided by 36 plus 44 plus 14 plus 14 plus 56 plus 54, which turns out to be 16.5. Like that, the fitness ratio of this is this. Fitness ratio of this is this, right? Total is 100. See, percentage 36. Right, so 100. And so this is Rolex Wheel 0 to 100, and you can now show that which chromosome has how much space there, occupied space there. It is proportional to the fitness value. You see, this chromosome has maximum fitness value, so it has occupied maximum space here, right? 25.3%. So 0 to 100 has been divided into this pictorially, and this called Rolex Wheel. And we can spun this wheel, and this is an indicator, right? So next time when we'll select chromosome, so this, wherever it stops, those chromosomes should be selected randomly. This is random selection, but randomness should be logical also. If this is occupying maximum space, so logically, most of the time, the indicator will stop here. So it will be selected in the next generation, like that. Okay. So this is Rolex Wheel. In gambling, somebody spun this, and then in gambling you do that. Okay, I will put, if it stop here, I will put some money, like that. I don't know. But Rolex Wheel has a very effective means in selecting logically fresh chromosomes with maximum fitness value. So we have crossover operator, okay, and let us try to see. These are my chromosomes which I have selected, right? And 6 chromosomes, and then each has the fitness value, and the chromosomes which has larger fitness value, I select them for mating. Say here, right? Which one is larger? This one, X5, and then X2. Say I decide that this should mate with this, and this should be mating with this. So you see, this is, and I decide also that how many to mate, right? I will create offspring. So what are the offspring after crossover operator? So this is in the ith generation. This is X6 chromosome, which is allowed to mate with X2 chromosome, and they are mating means they are exchanging the gene, and after mating, the new chromosome X6 will be equal to 1, 0, 0, 0, and X2 I will be 0, 1, 0, 1. Similarly, you see, this is after mating, X1I equals to 1, 1, 1, 1, and X5 equals to 0, 1, 0, 0. So we are assuming that we will allow 70%, 0.7, right? I have 6 chromosome, 70% of the chromosome I will um, crank out offspring by mating them. So 70% of 6 means 4.2 equal to 4. So 4 out of 6, 4 chromosomes I have selected 1, 2, 3, 4, 1, 2, 3, 4, and this is crossover operator. Crossover operator is your decision. Could be also 3 gene. You could exchange, but you see, the thing which you will have to see that whether drastically it should not be. Means changes should be slowly. So only 1 or 2 you just change in the gene. Are you getting my point, right? 70% crossover probability, 70% probability means I have 6 chromosomes. Out of that, 4 chromosomes I am mating with crossover operator. Okay, and these are the result after mating. And 2 other chromosomes having a high fitness value, right? We have kept it as it is for cloning. Okay, so total number dimension 1, 2, 3, 4, 5, 6, and now again you will have to calculate. You will have to calculate. So x2 0, 1, 0, 0, and x5 0, 1, 1, 1. So 6 chromosomes. Now you have function. Same old story. 15x minus x square, right? So this value is 8, right? And this is no, this is actually 0, 1, 2, 3 to the power 0 to the power 1 to square to cube. Yes, it is 8. And this is 2 0 to 1 to square 2 to square 4 equal to 5. This is equals to 8 plus 4 plus, so equals to 15. This is equals to 4. This equals to 4, and this is equals to so 4, 6, 7, right? So now put these values 8 here and calculate its fitness. You need to have a calculator. So it's very simple, isn't it? It turns out that the fitness value is 56. This chromosome's fitness value 5, right? 75 minus 75 minus 25 is 50. 50. Is it correct? 50. And then this fitness value is 0, and this chromosome's fitness value equals to 44. Just put, and then 44, then 7 into 5, 15 into 7, minus 49 equal to 56. Well, so you have this chromosome is gone, right? And you have in the next population, next generation, you populate 1, 2, 3, 4, 5, and maybe you can keep again. You check, please. You can keep 2 high fitness value chromosomes, because you need to make number of chromosomes same generation after generation. Okay. So this is what crossover operator is doing. Two gene, you are exchanging three gene, all kind of things you can do, right? So that fresh population you get. Then you run the algorithm and see that, okay, generation after generation, next generation again 6, and then again make out of 6 some 4 and met them and create fresh chromosome like that till there is no appreciable change. Appreciable changes means fitness values are not changing. It's a dangerous thing, right? So you'll have to stop and you'll have to mutate. Mutation operator you can just use. Mutation is actually flipping any gene randomly. Okay, say these are my chromosomes. This you replace with 0. Okay, and create new chromosome. This you can just replace with 1 and create a fresh one, fresh chromosome. So idea is mutation operator helps technically my search algorithm to come out from the local optima where it might be trapped. It might be trapped means fitness values are not changing appreciably. Now with mutation operator, even then if the fitness values are not changing, that means you have reached to the global optima, right? So there is no trap. So you should not and if the means fitness values are decreasing, that is worst kind of genes you have generated, then you stop there because before mutation operator already you have reached to the destination. Otherwise mutation operator you use and then run the algorithm. So cyclically you can do this, and you have to even you can do 3-4 iterations by hand like that. You see, you have Rolex Wheel, you have generation I, you have all the chromosomes, and then each chromosome's fitness value you have calculated. Because you have a fitness function here, you are blessed with a fitness function. There's a toy problem, and then you see you select best one, the X654 and 244. So these two I decide that this should be allowed to mate, right? This is called crossover operator. And 1 and 5, 1 and 5 crossover. So 2 gene will exchange. I decide that, okay, 2 gene. Here next time 3 genes I will exchange. I decide that because your idea is to create a fresh population, right? Chromosome. And 2, I decide that quite high fitness values. I'll keep them as it is. Cloning. This is called cloning. Okay, crossover and cloning. But please remember, total number of chromosomes, as I told you earlier, has to be same. 6 again. Okay, 1, 2, 3, 4, 5, 6. And then you should continue and again check fitness value. If it is changing, fine, go ahead, and with crossover operator you run the cycle till there is no appreciable change. No appreciable change means either the chromosomes which you have got are the optimal one, and highest values chromosomes you can select, those are the solution, highest and next highest, because this genetic algorithm is all about means giving you a global kind of solution which is not as precise as 7.5, for example, in this particular case, but in real real problem, real solution, it will be nearer about 7.5. Okay, and then if it is trapped, then mutation operator you can use, you exchange, and then again generation I plus 1. So with crossover, with mutation, next generation you are going. Again you calculate the fitness values of all the chromosomes, and then you select them, and then crossover operator you can use. You can crossover between these and these, and take this to as cloning. This is your choice. Randomly you should do, show that fresh means this should improve. Okay, the total, the average fitness value should improve. Average fitness value means, you see, here average fitness value has 36 plus 42, 44 plus 14 plus 14 plus 56 plus 54 divided by 6. So whatever it is, this is say something like 32 or something like that. And then without mutation you can just create, so these are the your creation 1 0 0 0 and then you have 0 1 0 1, you have 1 1 1 1. I told earlier, right? You have 0 1 0 0, then you have 0 1 0 0 0 1 1 1. So with all this you calculate again fitness value, and see average fitness value should be greater than this. If it is 36, it should be something like 40 44. You can calculate. Okay, because you have the fitness. So is it clear, how it is going on? And then if average value increasing, fine, you go ahead and repeat crossover operator again and again till average values are improving. If not improving, appreciably not improving, you use mutation. Then again you calculate the average fitness values, right? If average fitness value is poorer than earlier, then mutation has produced bad result. That means earlier what values you have got, take the top two, those are your solution. As simple as this. So you have understood the genetic algorithm cycle. So this is, I can give you any example, right? So that you can do it by hand. All of you can do it by hand. Okay, 3x minus x square. Or I can give some function 2 minus x square, 2 minus x cube, whatever, right? So please do this hand problem, codify, run this cycle, okay? And learn each and every step of genetic algorithm. So Rolex Field, role of Rolex Field is clear, right? It allows you, the fetus chromosome, to take part in the mating process in the generation after generation. Crossover operator allows you to generate fresh chromosome, okay, offspring. Mutation operator helps you to come, if my search algorithm, this is search algorithm, right? It is trapped in the local optima. Mutation operator technically helps my search to come out of the local optima, and fresh cycle again can start. And this is pretty simple, isn't it? This is all about genetic algorithm. And then we will see with some more examples that why it will always work. You see, I have done some, taken the example of nature, and then what is going on in the nature, I try to emulate it in silico, and I am getting good results. Okay. So first of all, you will see 7.5 you are getting by hand. Here also 2 chromosomes, fitness values, and average. So X value you will get. So this is giving value. This is also this chromosome and this chromosome. So average of these two will be your solution, and you will see it is coming nearer to 7.5. So with this I conclude and give you assignments. Any fitness function I will give, any function I will give, and I will ask you to solve the optimization problem using basic genetic algorithm. So this is called basic genetic algorithm, binary coded genetic algorithm, and how it works you have seen. Now, next lecture I will tell you why always it works using schema theory. So stay tuned. Till then, have a nice day.